Okay. All right, now, here we go. All right, you don't want that to be on the recording. Okay, we are starting. Okay, now, and pretty much what we're learning to solve, listen please, what we're learning to solve are equations such as these. This is called a radical equation. We're not going to solve this particular one. And then what I've given you are, again, these will have meaning as we start doing examples. I'd say the most important one is this one right here. Whenever possible, isolate a single radical term on one side of the equation. And then the second one, I would also add the second one is hugely important. Raise each side of the equation to the power equal to the index, meaning if it's a square root, we're going to square both sides. If it's a cube root, we're going to cube both sides. If the equation still contains a radical term, repeat steps 1 and 2. We'll get to special situations like that. 4 is check possible solutions to the original equation for extraneous solutions. Now, what an extraneous solution is a solution that algebra revealed, like x equals 3 is a solution, but when you check it, it can't be that, and you didn't actually make any mistakes. That's going to happen with these once in a while. We're going to see that. All right, next page. So, here's our first equation we're going to solve. So, when you have root x, and always leave the original equation intact. Root x equals 6. What we're going to do, these are not hard to solve. We are simply going to square both sides. Okay? And that will get us what? X equals 36. Now, when I check this, you'll see this works out very nicely. Is the primary square root of 36, does that equal 6? 6 equals 6. Done, right? So that's our solution here. Does that work? Are we okay? Now, look what happens when I do those. Well, I plug in my solution in for x there, right? And I ask myself, is the primary square root of 36 or the positive square root of 36 6? Yes, it is. Now, look what happens when I use that same procedure on an equation like this. The square root of x equals -5. Now, I'm going to square both sides, right? And I get that x equals 25. But look what happens when I try to check this one. I get, is the primary square root of 25 equal to -25? I'm sorry, equal to -5. And that's no, right? Because the square root of 5, so my solution here is null set, right? Or no solution. So, because the primary square root of 25 is positive 5, right? That's not negative 5. Okay, so let's go down below here. So, original problem, right? And you go to homework, always leave the original problem intact, otherwise you're not going to know what you started with. So what do you think I'm going to do here? Plus 4. The root quantity x plus 4 squared, and I'm going to square 6. Remember, that's just another property of equality. If I square both sides of something, the equation should still be true, right? Just like multiplying the same amount on both sides, dividing, subtracting from the same amount on both sides. So what do I get here? X plus 4 equals 36. Subtract 4, and I get, sure this is closer, and I get what? I get x equals 32. Now let's check it. So remember, into the original equation, which is root 32 plus 4, does that equal 6? So that's root 36. Remember, put a question mark there. 6 equals 6, so that checks, so that's a good solution. And so far? Now, you notice one of the criteria on the first page said that we want to always isolate the term with the radical in it as our first step. So before I square both sides here, what do you think I should do? Add 3 to both sides, okay? That's a key step there, right? So I get root x minus 5 equals 7. Okay? Now I'm ready to square both sides. And I get what? X, no, I'm getting plus 5.
Equals 49.
Equals 49. Remember, when you square a radical, you always get the radicand. Okay? So we get x equals what? 54. Let's check it. That is root 54 minus 5 minus 3. Does that equal 4? Well, what's that? That's root 49 minus 3 equals 4. That's 7 minus 3. 4 equals 4, right? So that's a good solution.
Go on, check on the one.
Yeah, I do. Okay, next page. All right. So same kind of problem. What do you think I should do first? So root 5x plus 9 equals what? 3. Square both sides. What do I get? 5x plus 9 equals 9. So over here. Subtract 9, and I get 5x equals 0. So does x equal here? Let's see if that works. Root 5 times 0 plus 9 plus 4, does that equal 7? So that ends up just equaling root 9 plus 4 equals 7. 3 plus 4 does equal 7. 7 equals 7. And so that checks up, so x 10 equals 0. That's a plausible solution. I think you're going to see this next one, though. Here's where we're going to run into an extraneous situation. Am I going too fast? Okay. All right. Now, the reason I'm showing you this, these look very similar. So why am I bothered? Because this one will have an extraneous solution. So what do I do first here?
Subtract 4.
Subtract 4. I think your antenna should go up when you get a negative on the other side like this, okay? I'm trying to remember that. So now I'm going to square both sides. And make sure you square -1, right? So I get 7 minus 5x equals positive 1. Why? Not now. Hold on a second. I hope that doesn't mess up the broadcast here. Hold on. Okay, there we go. Equals 1. Yes. Because we always want to isolate the term of the radical in it. Okay. I mean, I added 4 where?
Like, it was in
I
the chat.
subtracted 4. Because I always want to isolate the term with the radical in it before I square both sides.
Oh, there wasn't 4 in the original problem.
Yep. Okay. All right, so step 2, what are we doing? Subtract 7.
It wouldn't. Oh, there you go.
Then I got negative 5x equals negative 6. Divide by negative 5. So my possible solution here is what? 6/5. And I gotta get what I can do the original equation. So let's try checking it over here. Root 7 minus 5 times 6/5. Does that equal, or plus 4, does that equal 3? And this is what? Root 7 minus 6 plus 4. You end up with 1 plus 4, and you can see that doesn't equal 3, so This one is another null set, right, or no solution.
Just for security.
Okay? All right. Now, one of the things, it looks like I got about, that's a little slow up there. I've got about 6 or 7 minutes. Now, one thing I'm not going to get to, you're going to absolutely have to watch is the distance formula, because you probably did that last year, but you know, you'll need a refresher on that, so make sure you finish the notes on this. Okay, so what am I going to do on this one? Do I have the term with the radical isolated?
Yes.
Yeah, I'm going to square it, right? Now, I've got to square this binomial. We really have to do, if we don't square this binomial properly, we're never going to get home to the right place. So this is the easy part. What happens when we square root x plus 5? It's just that, right? Now, this is squaring a binomial. This is going to be your x squared plus 2ab plus b squared pattern. We can't forget this. This is x squared plus what? 2 times x times 5 plus 5 squared. If you don't understand where this comes from, do FOIL on x plus 5 plus x times x plus 5, and you'll see why that is. Okay, so what should I do now?
Subtract 5.
I'm going to subtract 5, that's correct. And so let's go over here since I'm running out of room. And I've got x equals
Wait,
x
but what you
squared
yeah.
plus 10x plus 20. What's next? Subtract x, right? And now I'm going to resort to my, remember the last year where all this ties together, right? Solve by factoring. Solve by factoring. Yes, sir.
Wouldn't it be plus x squared plus 9?
Yeah.
Sorry, plus, thank you. Very good. So how do I solve this by factoring? What's the factoring of x squared plus 9x plus 20? Come on, folks. Last unit.
X plus 5, X minus.
X, no, it's actually just going to be x plus 5, x plus 4, right? Right? Okay.
Why do you have to?
Well, we'll check. Anthony just asked are the two answers? Maybe. For now, we think there is. So we got x plus 5 equals 0, or x plus 4 equals 0. So we're going to check to see if -5 and or -4 are solutions that work. So let's check. Let's check -5 first. Root -5 plus 5. Does that equal -5 plus 5? That one does work, right? So I get root 0, which is 0 equals 0 here. That one works. Are we okay on that, why that worked? I don't think the other one's going to work. So then we're going to plug in -4. Actually, I think it is. Let's see. -4. Remember, what's the original equation? -4 plus 5. Does that equal -4 plus 5? Because I had to use the zero products property up there. And I end up with root 1 equals 1, 1 equals 1, so that one checks too. So they were good solutions, 2 solutions on that. All right? Okay, let's do one more and then I'm gonna let you guys go, pause the video and go. Okay, so I can tell you, I'm gonna be for sure shortening the assignment, so check your email when you get home. Okay, what do you think I'm gonna do here first?
Add X.
I gotta isolate the triangle. Add x. And I've got root 2x plus 2 equals what? I'll write, what's a better way to write this? What do you think I'm gonna end up writing this over here? I'm gonna write x minus 3, right? Is that okay? Instead of negative 3 plus x. What do you think my next step is? Next step, folks.
Square it.
Square it. What's this equal?
2x plus 2.
2x plus 2.
X squared.
X squared minus 2 times x times 3. And then we're going to call that plus 3 squared. Because it's negative 3 times negative 3. So that's 2x plus 2 equals x squared minus what?
6x.
6x plus 9. Next step.
Minus the 2.
Subtract 2. 2x equals x squared minus 6x plus 7. Subtract 2x. And I'll have a 0 equals x squared minus 8x plus 7. Factors of positive 7 that sum to negative 8.
Negative 1, negative 7. Hi, right.
Good. Okay, zero products property. So continuing with the check here. My equation is 2x, actually 2x plus 2 minus 6 equals 3. So I'm going to substitute on first check x equals 7. Plus, let's do plus 2 minus x equals negative. Plus 2. I can't remember what it is. Minus x equals negative 3, so minus 7 does that equal negative 3. And so that's going to be 14 plus 2, so that's root 16 minus 7, that equals negative 3, so that's 4 minus 7, that does equal negative 3, so that checks out. And then I'm going to go root 2 times 1 plus 2 minus 7, does that equal negative 3? And so I end up with, on this one, I end up with root, no, not minus 7, minus 1. So I end up here with root 4 minus 1 equals negative 3. And then 2 minus 1 equals negative 3, and that is not true. 1 does not equal negative 3. So that can't be a solution. So my only solution is going to be x equals 7, x equals 1 is excluded. So next page, all right? So then I've got root 3x plus 3 equals 3 root x minus 1. Once again, I'm going to square those sides. Now this is a little bit unusual in that I do have a number outside, so that will have to get squared also. So that's going to be 3x plus 3. This will equal 9 times x minus 1. Squaring, when I square, so what really happened here is I squared 3 and I squared I squared root x minus 1. And so that's why that just is an x minus 1. We got to do a little distributive property over here. 9x minus 9. Putting the variable on the same side by subtracting 3x. And I'll have 3 equals 6x minus 9. And I will add 9. And I'll get 6x equals 12. And I get x equals 2. I'll try checking that real quick. So it's root 3 times 2 plus 3. Does that equal 3 times root 2 minus 1? So that is going to be 6 plus 3, that's root 9. Does that equal 3 times, that's going to be a 1. So that's 3 equals 3. So that checks. So x equals 2 is a good solution. All right. So let's look at the next one. Once again, on this one, what I can actually do, just to take the 2's out of the picture, since both sides have a 2 being multiplied, I can just divide out the 2's. So now I just have root 4x plus 5 equals root x plus 4. So a little easy thing to do if you have the same number on both sides. Then I'm going to square both sides. And I'll end up here with 4x plus 5 equals x plus 4. I'm going to subtract x from both sides, and I'll get 3x plus 5 equals 4. I'm going to subtract 5 from both sides, and I'll get 3x equals negative 1. Divide by 3 on both sides, I'll get x equals negative 1/3. So I need to check that in the original equation. So I'm going to say 2 root, move this over. 2 root 4 times negative 1/3 plus 5, does that equal negative 1/3 plus 4? So, and that's got a 2 also. So I've got 2 times negative 4/3 plus 5, so that's going to equal, so that's 15/3 plus 4, so that's going to equal negative 2 times negative 11/3. Does that equal 2 times 2 times, so that would be 10/3. And, sorry, that would be 11/3. And those are not equal, so this is an excluded solution. So no solution again on this one. Okay, now I have a cube root equals, I have a cube root involved. Instead of squaring both sides, what I'm going to have to do is cube both sides. So that will clear the radical on this side, and then that equals 64. I'm going to add 5 to both sides, and I'll get 3x equals 69, divide by 3, and I'll get that equals x equals 23. So I'm going to check that one over here. I'm going to have, so that's the cube root of 3 times 23 minus 4 equal 4, and so I get sorry, I made a mistake right here, that should be 5. So I end up with, that's the cube root of 69 minus 5 equals 4, well that's cube root of 64, and that does equal 4, so it checks, and so x equals 23 is a good solution. Now I'm going to have the fourth root of x plus 18 equals 2. I'm going to take both sides to the fourth root this time. And so that will give me x plus 14 equals 16. And so I subtract 14 from both sides, and I get x equals 2. And when I plug that back into the original equation to check it, I end up here with the fourth root of 2 plus 14. Does that equal 2? And I get the fourth root of 16. That does equal 2. 2 equals 2. So that's a good solution. Now, what we're doing in this next type problem is we're going to be using the distance formula, which is an application of solving radical equations. So I'm trying to find the distance in a coordinate plane between the points -12, 6 and 8, -9. So let me actually change my scale here. Okay, I apologize to those of you in my red class. We won't have the point -12 on there, so just go off the graph a little bit. So, -12, 6 is the point right here. And 8, -9 is this point all the way down here. And I'm going to get a line through there. Now, so what I'm trying to find out is the distance what I'm trying to find out right here is the distance between these 2 points. What that distance in units is. So where the distance formula comes from is, if I was to do this without the distance formula, what I would do is I would realize I can create a right triangle and use the Pythagorean theorem. So this distance is from here to, in terms of the x difference, the difference of their y's actually is the distance from 6 all the way to -9, so that is a distance of 15. And my difference of my x's is going from, the difference of my x's is going from -12 to 8, so that is a 20. So what the distance formula is essentially doing is it's finding, like, my x-coordinate over here is -12, and my x-coordinate over here is 8. And so what I'm doing in the distance formula is I'm finding the difference of the x's like I do with slope. So if this was my x2, let's say this is my x2, if I want to find the difference of my x2 minus my x1, which is this -12, I would say 8 minus -12, and I would get that is 20. So that gives me that horizontal leg right there. And if I had done it the other way around, I would have gotten -12 minus -8, I would have gotten -20, but when you square it in the Pythagorean theorem, it ends up positive, so it doesn't matter which you take as point 1 and point 2. And then I have my difference between my y's, which is, that's the point 6, and this is -9. So my difference of my y's is y2 minus y1. So let's call this y2 and y1. And so here I would have -9 minus -6. That's -15. So when I'm plugging into the distance formula, I would plug all that in there. You'll notice I got my x2 minus x1, I got 20. I'm going to square that, and then, again, this is Pythagorean theorem, inside here, this is like your a squared plus your b squared, and take the square root of it all to get what c is. You want to know what c squared is, you want to know what c is. So this is -15 squared, so this is d equals 400 plus 225. So I get d equals root 625, that's a perfect square, d equals 25 units. So that's how I use the distance formula. And then you have some word problems to do. Here's an example of a word problem. Einstein's theory of relativity predicts that an object moving at speed v will be shortened in the direction of its motion by a factor of f, given by this formula, where f equals 1 minus v squared over c squared, where c is the speed of light. Solve this formula for v squared. So we're actually just rearranging this, solving a little equation. So I'll rewrite the formula. So if these were numbers, and maybe just one variable involved, what would I do? Well, I would square both sides. And so now I have f squared equals 1 minus v squared over c squared. Now I want to get the v squared by itself, so I'm first going to get rid of this 1, so I'm going to make this f squared minus 1 equals negative v squared over c squared. So if I want to get rid of the negative and the c squared, I'm going to multiply both sides by, just rewrite it, I'm going to multiply both sides by negative c squared, and by the way, this equation said solve for v squared, not v, so I don't have to worry about things when I get v squared alone. So this will give me v squared equals, and I think we'll probably leave this, we could leave it like this. Let's make it, after I distribute this c squared to this negative 1, that'd be positive c squared. So I'll write that first, and then negative c squared times f squared would be minus c squared f squared. So a couple of ways you could write this final version of what v squared equals, but we'll leave it like that. That's the end of the lesson.